Welcome back, everyone. So I already kind of told you what was going on in the next four examples. So I know they're not numbered right. I know. Just go ahead and get mad at me. I know. Okay, so these are examples 4, 5, 6, and 7. So just know 4, 5, 6, and 7. Okay, but anyway, so this examples 4 through 7, what we're going to do is reverse what we did in example 1 through 3. So in example 1 through 3, I gave you a quadratic equation and you had to tell me or state the transformation. Well, in these, I'm going to state the transformations and you have to build an equation. So based on what I've given you, you have to figure out, well, what is the A, H, and K value and build your own equation, which in the ones we did in example 1, 2, and 3, you only had one value to worry about at a time. Like you either had just an A, just an H, or just a K. Well, in these problems, we're going to combine at least two transformations together. So it's going to get even more excited. The more transformations, the better. Let's get started. Okay, so first, in example 4, this is example 4 where it says the 1. Okay, the graph is going to move left 5 and up 2 spaces. So based on the transformations, I need to identify if these are A, H, or K values, and then I'll know the appropriate spot to fill in the value. So when we go left 5, what do you guys think? Which transformation goes left 5? Well, let's go back and cheat for a second. Just take in the slide. If you go to the left, which transformation are you dealing with? When you go left, you're dealing with an H value, okay? So, when we go left 5, that's an H value. Don't forget, with the H value, we have to think the opposite. So when we think left, we tend to think, well, we're heading to the left on the X, which means we're going negative. Now that's the demon cats talking to you. Okay, that's what the demon cats will tell you, and you'll put a negative sign. Don't do that, okay? When you go left 5, it's actually going to be a positive number. Okay, so we have our standard form of quadratic transformations. I know this is an H value, so I'm going to be filling in a value for H into my new equation. So since I'm going left 5 spaces, it's going to be X plus 5, because we think the opposite. Now if we're going up 2 spaces, do you guys remember when you go up or down, is that an A, H, or K? Holy hot dog, that is a K. You guys are brilliant. Okay, so the K value will tell us we go up or down, which we're going up to. Remember, you don't think the opposite with the K value. So if you go up to, going up is a positive direction, so your K will be a positive 2. So in the K spot on the very end, I'm going to fill in where the K goes. So that goes after your parenthesis on the end. It will be a plus 2. So this is the equation that represents a graph that will go left 5 and up 2. So this would be the answer to example 4. All right, let's get started on example 5 now. All right, when we go right 3, which transformation takes us either to the left or to the right? Exactly, you guys. That would also be an H value. Okay, just like up here, going left was H, so going right still an H. Whoa. I did not mean to zoom in that far, but that was kind of cool. I wish I would have planned that, or it would have been even more exciting. Oh well, but anyways, it was still pretty cool. So if we go right 3 again, the H value, we have to think the opposite. So remember, if we go right 3, we're tempted to think plus 3 because going to the right is a positive direction, but that's when the demon cats will get you. So we think the opposite, which means our H will actually be subtracting 3. Okay, so here's our standard form again. So when we fill in the equation, the H value is whatever is added or subtracted to the X. Okay, so I know it's going to be in my parenthesis. We're going right 3, so we think the opposite. So this would be A minus 3. All right, and our final transformation in example 5 is we're going down 1. Okay, which value makes you go up or down? The A, H, or K? Well, like up here, when you went up 2, it was a K, so when you go down 1, it will also be a K. And the K value is whatever's added or subtracted on the very end of your equation. And with the K value, you don't think the opposite. So if you go down 1, going down is a negative direction. So your K would simply be A minus 1 on the end. So there you go. Your equation that represents going right 3 and down 1 is y equals x minus 3 squared minus 1. All right, example, let's see here, 4, 5, 6. We're on example 6 now. All right, so in this one, we are flipping over the x-axis, going left 2 and down 3. Whoa, we got 3 transformations going on. It's getting serious. Okay, so if we flip over the x-axis, what do you guys think when you reflect over the x-axis? Is that an A, H, or K value? What do you guys think? Well, when you flip over the x-axis, that's reflecting over the x-axis, and if you guys remember, that is an A value. Okay, so we have our standard form. Again, if you like stacking the standard form on top of the equation, you can. I just didn't have enough space, so I'm going to write it over here. But if you like the way I've been doing it, you can still like stack your equation and draw arrows down to write your answer. Okay, so I know it's an A value. A is the number that is right in front of your parenthesis before the x squared, or the parenthesis with the x minus h squared. Okay, so I know it's going to go at the very front. Now, what value do you use for A? What is the A value when it is reflecting over the x-axis? What would that be? Precisely, you guys. When it reflects over the x-axis, it's a negative value, and if you don't have any other A value transformations, it's simply a -1. Or if you want to be a lazy mathematician, you could just put only a negative sign out in front. So I'll leave it up to you guys. Okay, if we go left 2, which value goes to the left or to the right? That would be an H value. Don't forget, you got to think the opposite. I didn't have enough space to remind you. Okay, so if we go left 2, remember the H is whatever's added or subtracted to the x inside your parenthesis. We think the opposite. So if we go left 2, would it be x plus 2 or x minus 2? What do you guys think? Of course, you guys know the right answer, like you always do. It'd be x plus 2. So the H is inside the parenthesis, and it's going to be a plus 2. Now, lastly, if we go down 3, which transformation goes up or down? That would be the K value. So the K value is on the very end. It's whatever's added or subtracted on the very end after the squared. Okay, and then you don't think the opposite with the K. So if we go down 3, are we going to be adding or subtracting 3 on the end? Yes, that is correct, you guys. You would subtract 3. You guys are on a roll. So the equation that will flip your graph over the x-axis, make your graph go left 2 and down 3, would be the equation y equals -1 or just negative, x plus 2 quantity squared minus 3. All right, our final example that pertains to these same concepts is example 7. Okay, so again, let's look at our first transformation, a vertical stretch of 3. Which letter vertically stretches or compresses your graph? An A, H, or K? What do we think? That would be an A value. Nice work, you guys. Okay, so here's standard form again. The A is the number in the very front of your equation, right before the parenthesis or the x squared. Okay, so that's where I'm going to put it in my actual equation. Okay, and when it vertically stretches by 3, the A value is simply just a 3. Oh, well, I messed that up. That should have been a 3. Well, that's embarrassing. That should be a 3, you guys. Sorry, I'll fix that right now. Jeez Louise, Miss Long. And now, don't look. You guys are going to see. See, I just messed this one all up. I must have not fixed it. Good golly. Sorry, guys. How embarrassing. Sorry about this, you guys. Wow. Okay, well, now it's going to be all messed up, but that's okay. But anyways, and now I have to go all the way through this again. Okay. Sorry. Okay, so the vertical stretch by a factor of 3, again, that's an A value. We're going to write that at the very front. Okay, which, there we go. So the 3 is going to go in front. Okay, and then if you see, we have a translated up. Do you guys remember which value goes up or down? That would be a K value. Okay, so the K value goes up or down. Okay, and that's going to go on the very end, and you don't think the opposite with the K. So I'm just going to put a plus 2 on the end. Now, if you guys see here, I did not have an H value in my equation. Okay, so that's why I don't have like an X minus H. technically if I don't have the h value, technically your h should be a 0, but anything minus 0 is itself. So if you did x minus 0, it would just be x. Okay, so if you don't have an h in your problem, it's just going to be an x squared. No x plus or minus anything. Okay, and again, I apologize about example 7. The demon cats obviously got me, but it's okay. We made it work out. So the vertical stretch of 3 made our A3, and the translated up to, or going up to, would make our K value a positive 2. Well, that's it, you guys. So now you guys know not only how to identify transformations from an equation, but also how to build an equation based off of your transformations. Now, in the next example problems, this will be where it gets really fun. In example 8 and 9, our last two examples, I know it's not numbered correctly, but it's okay. You guys will actually be graphing each transformation and stating the transformation. So it's kind of combining everything we've learned about transformations so far, which is pretty cool. Okay, I don't want to give much else away, but that's it, you guys. So nice job. Get pumped up for our graphing example problems.